2 meters long, no mouth, no stomach, no gut, and it thrives in total darkness at the bottom of the ocean. In February 1977, the submersible Alvin dove to the Galapagos Rift, hunting evidence of hydrothermal vents. What it found was an oasis of life, so dense it forced a new question. What if an ecosystem doesn't start with sunlight? The answer is chemosynthesis, microbes that use chemical energy, like hydrogen sulfide or methane, to build organic matter from CO2. Rock and seawater become the fuel. That mouthless giant? Riftia pachyptilla, the giant tubeworm. It's basically a living habitat for bacteria. Inside is an organ called the trophosome, packed with chemosynthetic microbes. The worm pulls in hydrogen sulfide, a chemical that's highly toxic to most animals, and delivers it to its symbionts. They use that energy to turn CO2 into food. The tubeworm lives off the results. And here's the bigger twist. This isn't fringe biology. A major synthesis of deep life research suggests around 70% of Earth's bacteria and archaea may live in the subsurface, kilometers down, powered by chemistry. Life might not be a thin film on a planet's surface. It might be something geology lights up, wherever rock meets water meets energy. Which raises an obvious question. Where else does that recipe exist? Rock, water, energy. We've already found clues, and they're closer than you think. Tomorrow, the ocean world where all of this might be happening right now. If 70% of Earth's life might be running on chemistry we barely see, how would we even recognize life somewhere else? Drop your take below.